So guys, very important term is this. What is electrolyte? First of all, tell me. Electrolyte means species which furnishes ions, right? When will they furnish ion? Ions कब provide करेंगे? So when they are dissolved in polar protic solvent, and the most cheapest and best solvent is water. So species which furnishes ion when dissolved in water. अब when you talk about examples, तो बहुत सारे मिलेंगे. As you know that NaCl, which is a solid, अगर आप उसको water में, excess water में, if you dissolve, you will get Na plus ion, which will be hydrated Cl minus ion. My dear, if you will take HCl, which is a covalent molecule, NaCl is ionic, HCl is covalent. So when you take that, and even if you are taking water, you will get Cl minus aqueous, and the H plus, which will not be free actually, because its electric field intensity is so high. At the same time, it's a very powerful Lewis acid, so it will take a pair of electron from water and it will form H3O plus. So basically you will get these ions. When I'm saying aqueous, you need to understand, like Na plus aqueous, what does it mean? It means that it is surrounded by, Na plus is surrounded by this positive, which is Na plus is surrounded by the dipole of water, partial negative, partial positive, and like this. And like that, so many other water molecules will be there. Right. Now the next question is, okay, sir, that means it may be a covalent molecule, it may be an ionic molecule, which can be an electrolyte. So electrolyte is not necessarily that it will be only covalent molecule. It may be covalent also, it may be. So these are the two best examples. Now let us classify this electrolyte. Classification. So when it comes to classification, how will we decide? When it comes to classification, how will we decide? Based on what? So this is based on degree of dissociation. So what it means? It means that suppose I took 1 mole of HCl, right? Suppose I took just 1 mole. Up to what extent I am going to get Na plus and Cl minus? Because Na plus NaCl is so strong that if you dissolve it, almost every single NaCl formula unit over here, that will decompose into Na plus, and I mean basically separate 1 mole and 1 mole you are going to get. Almost 0 mole of NaCl will left, almost. So here basically one I took and one entirely got dissociated. So degree of dissociation will be 1. How do we define? Alpha will be 1. How do we define degree of dissociation? How many moles consumed or broken into ions divided by how many moles we took at the beginning. Alpha 1 means 100% ionization or dissociation depending on the molecule. So when it comes to classification of electrolytes, we can divide it into 2 parts. Number 1, Strong electrolyte. Number 2, weak. The moment I am using the word strong electrolyte, which means the degree of dissociation is very close to 1. So it is understood that for weak electrolyte, the degree of dissociation will be quite less than 1. तो ये ध्यान रखना है, and accordingly you have to think. So classification of electro. So strong electrolyte tending to 1, weak electrolyte much less than 1. Now let's have some example. Like if I'll try to describe, so under strong electrolyte, we may get strong acid, strong acid like, guys, you know, HCl, you know, HBr, hydroacids, you know, HI, right? So these are hydroacid where there is no oxygen in between hydrogen and central metal ion. Now some oxyacid, stronger oxidized oxyacid like H2SO4. Like guys, HOCl double bond O, double bond O. Like my dear, HOBr double bond O, double bond O, double bond O. So hydroacid, we are having these 3 acids are really, really powerful. And if you want to add, there is one more, and that is HSBF6. That is also very powerful acid. So these are the list of the acid which I give you. Like instead of taking Br, you can take Cl also. Now, how will we know that? How to identify whether it is a strong acid or not? So I'll give you a very fundamental thing over here. You know, the difference between these two. What is the difference between these two? Let us deprotonate one of this H plus ion, right? Let us remove H plus ion. So what we are going to get? We will get O negative over here. These are the conjugate base. Means this is acid and it is its conjugate base by removing H plus ion. Now, can you see the basic difference between these two? The conjugate base here and the conjugate base here. There is a huge difference because there is only one terminal oxygen. Only one terminal oxygen which can stabilize the negative ion of this. So I should draw the structure like this, resonance O minus. Whereas what do you think over here? It can go like this. At the same time, my dear, it can go like this also. As you know, it is quite difficult to stabilize any negative ion. And it will be stabilized if we are having negative charge shared on high electronegative. So more the double bond O, which can share this negative charge, more will be the acidic strength. So it is considered to be a very strong acid. So from here you can take an analogy, whereas this is weaker acid. You can take an analogy that whenever we have 2 or more than 2 terminal oxygen, that will be considered as strong acid. So like this, अब देखो यहाँ पे 2 है, यहाँ देखो 3 हो गया, तो even stronger. तो ये ऑक्सी एसिड का क्राइटेरिया मैंने आपको समझाया. This is for valid for oxy acid. एंड यहाँ पे HCl, HBr, HI इसमें कैसे डिफाइन करेंगे? तो सी दीज आर हाइड्रा एसिड, दीज आर हाइड्रा एसिड. आप हाइड्रा एसिड में इनका Ka वैल्यू से ही डिटरमाइन कर सकते हो. Although let me tell you, when you draft all the hydra acid, you'll get an idea. Say for example, the reference solvent is water itself, so we will not discuss anything about it. Here we have H2S in the same group, then selenium, right? And to the right we are having HF, then we are having HCl, then we are having HBr, then we are having HI. Now when you compare in the same period and when you compare in the same group, then two different things we need to observe. जब भी आप पीरियड में डिस्कशन करते हो हाइड्रा एसिड का, तो पीरियड में अगर आप पीरियोडिक प्रॉपर्टीज थोड़ा याद किए हो तो यू नो दैट इन पीरियड देयर इज नॉट वेरी बिग डिफरेंस इन द एटॉमिक साइजेस टू एडजेसेंट एटम्स. जबकि अगर आप ग्रुप में बात करो बेटा, तो व्हेन यू आर मूविंग डाउन then atomic size considerably increases, and because of this only, what we can do, because of this considerable increase in the size, here dominating factor is atomic size, whereas in this particular case when you are moving in a period, the deciding factor is electronegativity, difference of electron. तो आप बताओ sulfur and chlorine, which is more electronegative? Obviously chlorine. So here H2S will break into H plus ion plus SH minus. जबकि HCl is stronger than this, so it breaks into H plus plus Cl minus. अच्छा, when you are moving down the group, this is acidic strength, right? When you are moving down the group, so as I told you कि size matters a lot. तो आपका जो Br minus है, that is more stable as compared to Cl minus, conjugate base stability. Bigger than size of the atom, the electron density will be very less per unit charge, partial minus, partial minus, partial minus. So it do not have that affinity for H plus and back. So that is why HBr is even stronger. So this was supposed to be weak, and they are all stronger. Even HI is the strongest among them. So that's how we used to, compare the acidic strength of the hydra acid and oxy acid. So for the strong electrolyte, what we are supposed to do? In case of acid, what we are supposed to do? Acid means hydra acid, HCl, HBr, HI, this H2SO4, anything which is having more than two or more than two terminal oxygen. Right? So these were the examples. Now coming to under strong electrolyte only, let us discuss something about base as well. So do we have strong bases also? Yes, we have. So we have strong base also. So what is the example of this strong base? So guys, please understand, all the alkali metal hydroxide or oxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, right? Francium is radioactive, I'm not talking about that. Now when you go to this side, beryllium, alkaline earth metal, magnesium, calcium hydroxide, and then strontium hydroxide, and then बेरियम हाइड्रोक्साइड, आपके पास ये सारा है. तो स्ट्रॉन्ग में ये सारे आते हैं. Even up to certain extent we consider calcium also, although not very good, but much better than average. But beryllium hydroxide, not even basic, ये तो amphoteric होता है. You know, it don't even dissolve in water. अगर आप इसको water में dissolve करो, you will not get anything. Nothing will happen. It exists as a precipitate. Like that, magnesium is also, but it is weak base. So it also do not dissolve too much, very slightly. So among hydroxide, if anyone will ask, you can say that these are the examples. That's it. That's what we have. In metal, non-metal, if we'll talk about, then we are having one more very good base, that is strong base. Very, very. O minus is there, N plus is there. So these are certain examples. Others are also there, but I'm not talking right now. I'm interested in hydroxide only. Basically, whatever the electrolyte, acid and base I'm taking right now is based on RNAS concept of acid and base, right? Now these were the strong bases. Apart from these, which is colored over here, there is no hydroxide of the entire periodic table which is basic. Now moving to, basic like this, strong base, right? Now moving to the third thing, that means salt. Now, if you talk about variety of the salts are there, variety of the salts. Some of them you would have heard in qualitative analysis also, right? There we get generally the wider picture. Like when you will talk about in salt, specifically if I'll go, then most of the salts of Na plus, you take NaCl, you take NaBr, you take Na2CO3, you take Na2SO4, you take Na3PO4, you take long chain fatty acid with sodium, कोई भी कंपाउंड ले लो, एनीथिंग, ये आप वाटर में डालते ही कंप्लीटली ब्रेक करते. You will find rare of the rarest example of Na plus इसका salt soluble ना हो, राइट? उसी तरीके से अगर आप बात करोगे तो सिल्वर का most of the salts of silver ion Ag plus is insoluble in water. There are very rare, and rare में कौन सा है? Nitrates of silver. And let me tell you, nitrates of most of the metals are soluble. जैसे मैं आपको बात करूं, NaNO3 of course soluble. Anyway, it is a compound of sodium. Okay, what about beryllium nitrate? Yes, it will also be soluble. Soluble means, my dear, whenever it will be dissolved in water, it will completely break into ions. And then it will be. So like that, we are having even zinc nitrate, even silver nitrate, full twice, even AgNO3, that is also soluble. ये भी soluble है. राइट? तो ये सारे केसेस हैं बच्चों. दैट्स हाउ यू आर गोइंग टू डिस्कस. एंड लेट मी टेल यू, अमोनिया के भी कंपाउंड मोस्टली सॉल्युबल है. अमोनियम आयन, सॉल्ट्स ऑफ अमोनियम आयन, like ammonium chloride, ammonium sulfate, they are mostly soluble, guys. Mostly they are soluble. And specifically when you will talk about, there are many compound of chloride ion which are soluble, except for the case of Ag plus, Hg2 plus 2, right? Chloride, bromide, iodide, these three are mostly soluble. Hg2 plus 2, right? And then Pb plus 2. which you already know now that they are I mean, these cations, chloride, bromide, and iodides are insoluble. After these three, I mean, you will rarely get any chloride which is insoluble. One more you can include, that is copper plus one, but you know that copper plus one in aqueous solution does not exist. That's why mostly this particular part is omitted. So we focus only these three. That is the very basic reason. So most of the compounds of Cl minus, so most of the compound of Cl, Br, and I except this. So these were the examples of what? Strong electrolytes.